If you watched the last video, you probably know that today we'll be talking about what differential geometry is and why would you ever use it. First off, you would use it in DNA studies while modeling DNA things, which can be very complex. Second of all, you can use it to find the curvature of the Earth, as we'll do later in the video. Third, we'll have this equation right here, which is the parametric curves, tangent vectors, the arc length formula, and finally the curvature formula, which relates to the Earth, and we'll use this formula later. Here's some problems we'll do, and don't worry, I'll help you get through them. First off, given RT is equal to TT squared. First off, the question asks us, what is xt and yt? Well, it's pretty easy, because x of t is equal to t and y of t is equal to t squared. As you can see here, they correlate. Next, we have, given rt is equal to t of t squared, find the tangent vector at t equals 2. First off, we'll do r prime t is equal to 1, 2t, because we'll take the derivative of both of them. T will be 1, and t squared will be 2t. If you don't know how to take the derivative, watch one of the previous videos that I made. Then, we'll plug in 2 over here, which will be 1, 4. Why? Because you substitute t for 2, and not the other one. So, the answer is 1, 4. The next question is, if xt is equal to cosine of t and yt is equal to sine of t, then what is the curvature? Well, we'll first have to take the derivative. Xt is equal to cosine of t, x prime of t is equal to negative sine t, yt is equal to sine t, and y prime t is equal to cosine of t. Then x double prime of t is equal to negative cosine of t, and finally y double prime of t is equal to negative sine t. So we'll here k is equal to negative sine t minus sine t minus cosine t, and then over negative sine t squared plus cosine t squared to the power of 3 over 2. Now, I probably didn't read that right, but you can read it right here. So you first simplify the numerator, which gives you negative sine t minus sine t is equal to sine to the power of 2t, which then becomes sine to the power of 2t plus cosine to the power of 2t. And because sine to the power of 2t plus cosine to the power of 2t equals 1, the numerator and denominator become 1, so the final answer to this monstrosity is just 1. Now, this is the next cool word problem. It involves a little bit of rocket science, but I'll get through it anyway. First off, a satellite is orbiting Earth in a circular orbit. Its position can be described by x equals r cosine of lambda, y equals r sine of lambda, where r is the radius of the satellite's orbit and lambda represents the satellite's angular position. Suppose the satellite is orbiting at a radius of r equals 7,000 kilometers, and its current angular position is lambda pi over 4. So, the question asks, what are the satellite's coordinates at this point in its orbit? Well, we can easily find that. This is the solution. So you first substitute r equal to 7,000 and lambda is equal to pi over 4. So x equals 7,000 cosine of pi over 4, y equals 7,000 sine of pi over 4, and we know that cosine of pi over 4 is equal to sine pi over 4 equals to the square root of 2 over 2. Therefore, x is equal to 7,000 square root of 2 over 2, y equals 7,000 square root 2 over 2. So it becomes x equals 3,500 square root of 2. Otherwise, we can use y is equal to 3,500 square root of 2, and the final answer would either be 3,500 square root 2 and 3,500 square root 2, or 4,949.7, 4,949.7 kilometers. Hope you found this pretty scary video easy.